we're going to look at today. This one, as you can see, involves two objects, so let's get right to it. What we do when we have multiple objects is we treat each one separately and draw a force diagram for it separately. And remember that objects can only feel the forces that directly are touching them. So the mass at the bottom will have no knowledge of the mass at the top. It only has knowledge of the rope. So what would those two diagrams look like? Well, there's the first one. There's the second mass. And in terms of forces, the mass at the top will experience this tension force T1 upwards, and it will experience a tension force T2 downwards. I'm putting that off center because it will also experience a force downwards due to its own weight. So that's the key. If you got that down, the rest of it will fall into place. Now, the mass hanging on the bottom experiences a force upwards from the rope, and then its own weight acting downwards, and nothing else. So let's label all of these. This would be T1, and then here we're going to have T2 and mg. Up here, we've got T2 and mg. Now, both of these masses have the same mass. Thus, I'm just labeling them at both mg. If they were separate, if they were different rather, I would label them m1g and m2g. So having done that, we now need to apply our little set of rules, which is easy enough to do. So step one, is there any acceleration? Yeah, there is. See, there's acceleration. It tells us in the question. So given that there is, we write down force equals ma. Now we're going to do each one separately, so let's do for the top one first. Next step, list all the forces starting with anything that is positive. Well, T1 was positive, then anything negative, so we've got minus T2 and we've got minus mg, right? All two, that doesn't make sense. Both of the forces acting downwards get their own separate term in the equation. Put those two things together, we get ma equals T1 minus T2 minus mg. And there is our first equation. Notice I haven't addressed what we're trying to find yet, because this process is one that we will apply every time. It's especially useful if you really don't know how to get started, how to approach a problem. Just follow these steps. You'll end up with some equations, and then hopefully you will figure out what to do with them. So there is acceleration, so ma. And again, because the masses are the same, they have the same mass. I don't have to separate them by labeling them m1 and m2. And they have the same acceleration, right? So they're both the same a. If they had different accelerations, I would have to call this one a1 and the second one a2. Now I'm going to list all of the forces. So upwards, I've got T2, and downwards, I've got mg. Put those two lines together, m1 equals T2 minus mg. So there's a second equation. Now I'm going to look and see what the question wants me to find out. It says, if the elevator has an upward acceleration of 1.6 meters per second squared, find T1 and T2. Okay, so if I look at the second equation over here, I'm looking for T2. If I know everything else, I'm good. Do I know the masses? Yeah, 2.95 kilograms. So mass, I know. Do I know the acceleration? Let's have a look. Too far? Yes, 1.6. So that's also a known. Mass again, g is always 9.8. There is only one unknown in this equation. I can solve for it. T2 equals ma plus mg, or m into a plus g. All right, good. Now I know T2. Go over to this first equation, and I'll do the same thing. Mass I know, acceleration I know. T1 is what I'm trying to solve for. T2 Ooh, do I know that? Yes, I do, because I just worked it out over here. I know m, I know g. There's only one unknown in that equation now too, so I can solve for t1. t1 equals ma plus mg plus t2. Simplify it slightly, m into a plus g plus t2. And there we go.